How could a tiny, weak creature on the fringes of the ecosystem overthrow an entire dynasty of giant reptiles to dominate the planet for 150 million years? The answer lies not in a war, but in a catastrophe so prolonged that life no longer recognized itself. "232 million years ago, the supercontinent Pangea was a deadly furnace. But then, a catastrophic geological upheaval broke the climate cycle. The sky ripped apart. The first drops of water fell on the arid desert, initiating an absurd event. Earth was submerged in rain for 2 million years. This was the Carnian pluvial event. Acid rain eroded limestone, and mud devoured ancient plants. The old rulers succumbed, unable to adapt to a world suddenly waterlogged and decaying. In that chaos, dinosaurs emerged. They didn't win by strength. They won because they were the only ones who could withstand the ferocity of the floodwaters. Forget the world map with the 7 continents you know. 235 million years ago, Earth was just a single, massive block of rock. The supercontinent Pangea, isolated in the vast Panthalassa Ocean. This concentration of land created a devastating survival problem. With a landmass stretching from pole to pole, moisture from the sea simply couldn't penetrate inland. The result? A vast desert dominating the center of the planet. In summer, inland temperatures frequently reached 122 degrees Fahrenheit to 140 degrees Fahrenheit. This wasn't just ordinary heat. It was enough to cook eggs and break any biological structure. Meanwhile, at the poles, organisms faced constant darkness and prolonged freezing for months on end. There was no regulation, no compromise. We're not speculating. Science has found the fingerprints of this furnace in rock layers across Europe and North America. These are layers of evaporites, minerals of salt, gypsum, and anhydrite. They only form when water evaporates extremely rapidly under intense heat, leaving behind deadly salt flats. These rock layers are irrefutable evidence of a scorched world, where life barely survived on the coastal edges. Why is this important? Because in that 140 degrees Fahrenheit heat, resources were stifled. The scarcity of vegetation forced the large herbivores of the time to expend too much energy moving and cooling themselves. The Triassic ecosystem was facing an evolutionary bottleneck. Everything was dry, cracked, and waiting for a spark. But this deadly stillness was the preparation for a great upheaval. When the geology changed, this furnace would transform into a giant basin of water. This arid world is coming to an end, giving way to something that will completely change the order of the planet. Before the flood, the planet's throne didn't belong to the dinosaurs. It was in the hands of rhynchosaurs, creatures that science describes as giant scaly pigs. They possessed massive, barrel-like bodies, thick and sturdy. Their ultimate weapon was their incredibly strong, horny beaks, specialized in crushing the dry, rigid vegetation of the Pangea Desert. At fossil sites, rhynchosaurs accounted for over 90% of the vertebrate population. They were absolute resource possessors, a vast army dominating all arid lands. Their direct competitors were cynodonts, the precursors of later mammals. A prime example is Exoretodon, a testament to the complexity of evolution. They possessed rudimentary downy feathers, a modified jaw, and were likely warm-blooded. Cynodonts possessed greater agility and metabolism than pure reptiles, but in the giant oven of the Triassic period, they were still second-rate, relying on plant-based diets and struggling to adapt to the harsh temperatures. Where were the dinosaurs then? They had appeared in what is now South America about 243 million years ago, but in the position of weak outsiders. Look at Eoraptor lunensis. It was only 3 feet long and weighed about the same as a large cat. Or Herrerasaurus, though a nimble predator, couldn't compete in size with the dominant species of its time. They were small, rare, and had to hide in the shadows of sparse coniferous forests to avoid being trampled. Despite their weakness, dinosaurs carried a valuable evolutionary investment: the structure of their vertical legs. Unlike the splayed legs of rhynchosaurs or other ancient reptiles, dinosaurs' legs rested directly under their center of gravity. This feature allowed them to move more efficiently, run faster, and conserve energy. In arid worlds, this advantage wasn't enough to overthrow the old order, but it was the key to survival when the environment changed drastically. If anyone had witnessed Earth at this moment, they would never have bet on dinosaurs. All resources, overwhelming numbers, and power were tilted toward the king of the desert, rhynchosaurs. Dinosaurs were merely a faint existence, a miscalculation of probability. However, history isn't written by the strongest in the present, but by those best prepared for disaster. The old rulers were about to face an enemy they couldn't crush with their horns: water. After millions of years of being scorched by the intense sun of Pangea, Earth suddenly transformed. Around 232 million years ago, an irreversible change began. Imagine layers of red rock, symbols of aridity, suddenly torn apart by something the planet had long forgotten. Dark clouds that blanketed the horizon. This wasn't a typical rainy season. It was the beginning of the Carnian pluvial event, a climate upheaval that would redefine the fate of life. Evidence of this invasion lies dormant in the Earth's depths to this day. As scientists delve deeper into the geological strata, they are stunned to find layers of fiery red desert rock abruptly replaced by dark coal seams and organic-rich clays. These layers don't lie. They are the remnants of waterlogged swamps, decaying forests, and a planet being washed away by water. The aridity died, giving way to a suffocatingly wet era. The most terrifying thing about this event was its scale. This wasn't a localized flood. From the Austrian Alps through the scorching deserts of Saudi Arabia, all the way to North America and China, all displayed a single pattern. Drought was killed by wetness. The world that the Wrangellias once ruled vanished in the blink of an eye in geological history. The longest reigns in history had begun, and it carried the death sentence for the old order, opening the door for a successor drenched in mud. The cause of the 2 million-year-long rain cycle doesn't come from the sky, but originates deep within the Earth. The most solid scientific hypothesis centers on Wrangellia, a massive igneous rock formation located in what is now western Canada and Alaska. Between 233 and 230 million years ago, a series of violent and continuous volcanic eruptions occurred. These weren't isolated explosions, but rather a continuous release of geological energy over millions of years, pumping enormous amounts of CO2 directly into the atmosphere. This excess CO2 triggered a catastrophic global warming event. Geological data shows that the Earth's average temperature increased by 5.4 degrees Fahrenheit to 18 degrees Fahrenheit. This soaring temperature heated the surface of the Pangea Ocean, pushing the rate of evaporation to extreme levels. The atmosphere was not only hotter, but also filled with water vapor, creating a huge potential energy source waiting to be released onto the supercontinent Pangea. The sudden temperature change disrupted previously stable wind patterns. Before this event, the interior of Pangea was a dead zone where moisture could not penetrate. However, the heat from the Wrangellia eruptions completely altered the global atmospheric pressure and circulation system. Moisture from the ocean was no longer blocked at the continental edge, but was pushed deep into the heart of Pangea. This was a comprehensive change in humidity patterns, transforming the driest deserts into low-lying areas receiving continuous rainfall. In short, the Carnian rains were not a random weather phenomenon. They were the direct physical consequence of a combination of large-scale volcanic activity and extreme greenhouse effects. The rain was merely the tip of the iceberg of a planetary-scale chemical and thermodynamic transformation. This very mechanism destroyed the stability of the Triassic period, directly creating tremendous evolutionary pressure on all living organisms, forcing them to change or be completely wiped out from the fossil record. The intensity of the pluvial Carnian event lay not only in the amount of water, but also in its duration. Over a period of 1 to 2 million years, a continuous flow from the sky completely transformed the landscape of the supercontinent Pangea. The previously arid, reddish deserts were wiped out, replaced by a network of rivers and enormous lakes. The arrival of a stable water source allowed gymnosperm and coniferous forests to expand from coastal areas deep into the interior, creating a biodiversity unprecedented in the Triassic period. When rains transformed the vegetation into succulents and dense forests, rhynchosaurs were unable to adapt to their new food sources. From a position of dominance, they nearly vanished from the fossil record in a short period. It wasn't just rhynchosaurs. Many other groups of organisms that were once thriving also suffered severe declines. Etosaurs, heavily armored reptiles, and some groups of phytosaurs were unable to withstand the sudden changes in habitat and food chain structure. Acid rain and changes in water pH may also have contributed to the destruction of their breeding grounds. This was a localized extinction event, but one with historically transformative effects. The Carnian pluvial event carried out a profound reorganization of terrestrial ecosystems. It didn't wipe out all life, but it swept away the greatest obstacles. When the old kings fell, they left behind a massive power vacuum in terms of living space and food resources. This was the most crucial moment. A new environment, wetter and more resource-rich, awaited a resourceful individual ready to seize it. And that individual had been waiting in the shadows for millions of years. We often think of dinosaurs as dominating due to sheer strength, but the truth in their early stages was different. They weren't the strongest or the smartest. Dinosaurs were actually lucky creatures, possessing biological traits that coincidentally fit into a rapidly changing new world. Unlike the splayed legs of other reptiles, their upright legs allowed them to move much more efficiently across mixed terrains, from damp, soft ground to uneven areas after cataclysmic events. Suggestions of a bird-like air sac system helped dinosaurs exchange oxygen more efficiently, a vital advantage in a constantly changing climate. In less than 10 million years after this event, dinosaurs experienced a biodiversity explosion. From large herbivores and carnivorous species of all sizes to long-necked forms, precursors of sauropods, and armored species, they quickly took over the ecological niches left by older animal groups. The key to success lies in adaptability, not in inherent superiority from the outset. However, the scientific community still has ongoing debates. Was its impact truly global in scale? What exactly was the role of volcanoes? And was the rise of dinosaurs a stroke of luck or an inevitable event? If you find this knowledge about adaptation interesting, don't forget to hit like to support the channel.